Right, still from the 1997 paper, just question 10 this time, because questions 10 and 11 were too long to put together into a single video. So pay attention to this pyramid, and then pause here and try the question. Question 10. There's a cuboid, a box with a square base and a certain height, sitting inside a pyramid with a square base, and it goes up until it hits the sides of it, and that forms its limit there. Then it says, show that the height of this box is given in terms of some amount of x. Well, the first thing we do this, what size is this pyramid? It says that the height of it is 10, its base is 8, so that half there would be 4. And there's a right angle triangle we can work with there, so I've drawn that to the side. So I've got this triangle whose height is 10 and whose base is 4. Now the box can only go up so far until it hits the edge, and that'll be half the box because that's the middle, so that distance will be x. And you have to figure out what's h in terms of x. Well, what you've got here are a pair of, this is a right angle triangle, those angles are the same, so that angle must be the same, so the lines are parallel, a pair of similar triangles. Similar triangles means that, if I take this part here, similar triangles means that they're actually the same as each other, just a different scale. There's that one there. The one, what I am holding, the smaller one, is the same as the big one, only reduced to a certain fraction. So it's just a case of what fraction has it been reduced to? Well, I'll put it over to the side and draw it again here. So there's that smaller triangle, drawn to the side, not too neatly, with its x there, and this part here, not the h, it's what's left over from 10. Now that is a fraction of the big one. That's the way similar triangles work. If triangles are similar, their sides are in proportion. They make the same fraction. So whatever fraction y is of 10, y over 10, that's the same fraction that x is of 4. The same fraction as x is of 4. So y is going to be, take the 10 across and multiply, 10x upon 4, so that's 5x upon 2. So that was y. The part I wanted was h. Well, h is just the whole thing. Take away that part y. That was the part y up there. So it'll be 10 minus 5x upon 2. So that was the first bit. It said, show that h equals that. That was part 1. Part 2 says, what's the volume? Well, the volume will be easy, because that will just be volume equals length times breadth times height. And it said the width of the base was 2x. So 2x times 2x times 10 minus 5x upon 2. So that's 4x squared times 10, 40x squared. 4x squared times that, 2 into 4 goes 2, so that'll be minus 10x cubed. That was the first bit. So it says, find the dimensions with the greatest volume. Greatest volume, want to differentiate. So dv by dx, that'll be 80x minus 30x squared. And it will have an optimum if that derivative ever equals 0. Because otherwise it's just going to be increasing forever or decreasing forever. And the only optimums, the only greatest and least values would happen at the extremes, at the ends, or at the ends of any interval, if there was a restricted interval. If it takes a turn, then that could be it instead. So find that optimum value equals to 0. That means 80x minus 30x squared should equal 0. So 10x comes out as a factor, leaving me 8 minus 3x equal to 0, which means either x is 0, which it can't be, or x equals 8 upon 3, which means the only answer is 8 upon 3, since if x was 0, there wouldn't be a box here at all. Now, the question says the dimensions, but first of all I should check, even though it said maximum volume, that in fact gives the maximum. So I'll just make up a table here quickly. I'll use a table of signs. I've only got to check 8 upon 3, nothing happened at 0. So something either side of it. I'm not going to put in values, I'm going to put in my factors, so I don't have to do any arithmetic. And then I can get my dv by dx at the bottom. Well, 10x is going to be positive there on either side. 8 minus 3x is a decreasing function. It'll be 0 there, so it'll be positive before, negative after. Multiplying the factors together gives me that. So I have in fact got a maximum turning point. You can either do that Or you could use the second derivative. I'll just put this here briefly. The second derivative just means to differentiate this again. So I've got 80 minus 60x. The first derivative means how fast are the points rising. So it's a measure of the gradient. The second derivative means now how fast are those gradients rising? How fast are those gradients changing? If it's a positive change, if the gradients are positively increasing, that means the line's getting steeper and steeper and steeper, which means it's curving upwards. But curving upwards, even if it was going down, if it's getting less negative, it's increasing. Curving upwards means a minimum. If that was negative, that means that the gradients were slowing down. That would give you a maximum. So at 8/3, you would just test at 8/3, what's the value of the second derivative? What's the rate of change of the gradients? So you put that into that, d squared v by dx squared would equal, again, it's not the number, it's only the sign I want. 60 times that, 20, 160, 80 equals 160, that's negative. And if the rate of change of the gradients is negative, it means they're slowing down. So you're going to have a turning point, it's curving downwards. So that means you've got a maximum turning point. So that's an alternative to using the table, if you wish, if it's a nice and easy thing to get the second derivative. So I've got the table there anyway. Right, now it's just a case to answer the question properly. What did it want? I found what x is. Does it want the volume? Does it want just x? Does it want anything else? No, it wanted the dimensions. So the dimension means length times breadth times height. So I'll say that. Maximum volume, don't just say of what, don't ask me that, just when the length, now the length and breadth are the same, so I'll just put them together. When the length equals the breadth, and that said was 2x, so that will be 2 times that, so that'll be 16/3 centimetres. Whoa, centimetres, I'll not underline that yet. And the height was given by that expression earlier, the 10 minus 5/2x. So it'll be 10 minus 5/2 times 8/3. That's going to be 20/3, so that'll just be 10/3. So that'll be 10/3 centimetres. Maximum volume when you've got this length, breadth and that height. That's question 10.